safe. You're all safe from Zach's musings. On the other hand, gentleman in the front row, his cosine squared comment, that stings more. This is a little more real to you guys. This one right here. that one, I like that one. That one feels like it could be a winner. It could be a contender. All right, lightning round. So here I'm going to show you just a couple examples. We should do at least one of these. So I'm just going to write down the particular solution in each one of these. Not the worked out one, but the template that you would use successfully. So what I'm going to write down are the things that the annihilator method would bring you to. Okay? So for this one, I look at it, I can see that the homogeneous solution is sine and cosine of t, because this is lambda equals plus or minus I. So that cosine overlaps. So I guess I'll take care of that first. I would do t times a cosine t plus b sine t to take care of the, that takes care of the overlap. And the t squared, well, I can just do, there's no overlap there, so I can just do ct squared plus dt plus e, and that'll do it. I can make that my particular solution. That should work. This one, and all of these things I'm saying right now, you could derive with the annihilator method, the way we did today. This one, it has homogeneous solutions, e to the plus or minus t. That's going to be a problem because I got e to the t here. Although it seems too simple, let me make it worse. Here, t squared, that's annoying, right? So I think with that, oh man, that one I'm going to have to actually work on for a second here. So I got d squared minus 1, just make sure I'm not wrong. I'm violating the rules of my lightning round, you can forgive me. To kill that, I need d minus 1 3 times. And this is so this guy I've expanded into those two. So this suggests to me that yp should be equal to, like, well, let me just write out the whole stupid thing. C1 e to the t plus C2 t to the t plus C3 t squared e to the t. How many do I got? 1, 2, 3, 4. 1, 2, 3. Well, I should have another one. 4 t cubed e to the t. And then plus C5 e to the minus t. So basically, this guy and this guy are my homogeneous solutions. So that should be my particular solution. So yp should look like t times at squared plus bt plus fine, at squared plus bt plus c, and I can factor the e to the t out. You know, I mean, well, there's a lot of different ways to package this thing. There's one. Well, this next problem is a welcome relief, because I can look at the number 3's homogeneous solution, right? And so if you look at this, it's lambda squared plus 4 lambda plus 5. That's lambda plus 2 quantity squared plus 1. So that says that lambda is minus 2 plus or minus I, which tells me the homogeneous solution has e to the minus 2t cosine t, or e to the minus 2t sine t as its principal members. And, well, those got nothing to do with t squared, so we're in luck. All we gotta do is write down the naive solution here. Good to go. yp at squared plus pt plus c, and that'll do it. Let's see here. This one. Oh no, I think I just sneezed into the mic. Is that cool? I didn't lose the thing. Sorry.
That would be compromised for something.
Don't sneeze into the mic. That's right. So this is d plus 1 cubed acting on y equal to e to the minus t. So if I annihilate both sides, right, I get that. And so basically, the highest term in the homogeneous solution to the fourth order problem is the particular solution. I've seen enough. Yp is equal to a t cubed e to the minus t. Like, what's yh here? C1 e to the t plus C2 t e to the t. Oh, minus t, right? I'm going to get minus t. Plus C3 t squared e to the minus t. So, because this guy overlapped down there, I had to multiply not by just t, but by t cubed to get out of the trouble zone here. So rather than having to memorize this like giant laundry list of how do you construct particular solutions, if you understand the annihilator method, if you're uncertain, it allows you to get out of the corner, right? And derive what the form of the particular solution should look like. But honestly, after you do it for a little bit, you don't have to do it anymore because you just know. In the process of deriving a few, you'll learn to remember the solutions, is my experience. But then again, I've been doing this most of my adult life, so I probably don't count. I don't know. Anyway, any questions about my ninja way? Sorry. That seems ridiculous when I say it. No questions? I think there's something else I'm supposed to tell you guys. Let's plus it. So the next step past this, right? These are not yet solutions, right? This is just a step on the road to the solution. Now what you have to do to actually find the solutions to these problems is do what?
Find the combinations.
Yeah, you gotta take it and plug it back into here and work out the ABC, and that's a pain, right? It's not a pain when there's no overlap. Like when there's no overlap, it's relatively simple. Right? This problem, to figure out ABC, we could do it in like 3 minutes. I won't, but I'm kind of tired. But you could easily figure this out. You just plug it in and equate coefficients. Maybe I should. Well, I can't. I'm
I don't even need to be watching the way it's plugging in. I can already tell you A is 1, the other is 0.
Oh, now you reminded me what I want to do. Thank you, Mike. Another fun thing you can do with this is go back to calculus 2 and look at it a really different way. Suppose you wanted to do something like integrate t squared e to the, let's use x, I'm tired of t, x squared e to the, e to the x dx. Well, calculus 3 style, this would be a pain, right? 2, calculus 2. I was having a conversation with Dr. Smith the other day about the idea that we should switch calculus 2 and 3. Make you guys take calculus 3 first and then calculus 2 second, like the latter. Because let's face it, which is harder? I mean, honestly, calc 2 is way harder if you're paying attention. I mean, like, it's got fancy stuff in there. Convergence, divergence theorems, those confused like the best mathematical minds for hundreds of years, and we expect you guys to do it as freshmen. Seems kind of like a jerk move, but it's our custom, so there you go. dy dx. So we're trying to solve what? We're trying to solve if this is equal to y, right? That's tantamount to saying dy dx is what? X squared e to the x, right? Now, I haven't told you guys about this, but it's true. It's in fact true that you know, you can. This is a differential equation, right? So what should I guess for yp? I should guess ax squared plus bx plus c times e to the x, because that's the naive solution. There's no overlap here. The homogeneous solution is just 1. Because the characteristic equation is kind of boring. It's lambda equal to 0. So like YH is just 1. It's C1, sorry, C1. Okay, it's kind of uneventful. But what's YP prime? So we got ourselves 2ax plus b. Well, let's just get to the point here. Plus ax squared plus bx plus c times e to the x. Right? And that has to be equal to what? X squared e to the x, right? So you look at this, you look at that, equate coefficients. So like, let's see here, 1 x squared e to the x. What's that give me? 1 equals to, let's say a, all right? X e to the x, what we got? 0 equal to 2a equals c, right? So therefore b is what? Minus 2, okay. And how about the e to the x term? What we got there? 0, b plus c. So what's c? 2. Consequently, the integral of x squared e to the x dx is x squared e to the x minus 2x e to the x plus 2 e to the x plus a constant. Is that easier than integration by parts? 2 times. Maybe not for e to the x, but what about e to the 7x? Yes, this is easier than integration by parts. Oh, maybe you know that table method, but I don't know about that, so whatever. The difference between the table method and this is actually part of a larger mathematical plot. Anyway, I shall shut up. You guys have the rest of the week. You guys are not sick. This is interesting. Like my Calc 3 class, they're like, and then of course there's a test today, right? So they're all there, making each other sick. It's just awful. My chest is